Assalamualaikum warahmatullahi wabarakatuh. We will be presenting our assignment about PISO 4-bit for the introduction. Shift register is a group of flip-flop. Shift register basically consists of several single-bit D-type data latch, one for each data bit, either a logic 0 or a 1, connected together in a serial type arrangement so that the output from one data latch become the input of the next latch and so on. The parallel in to serial out shift register act in the data is loaded into the register in a parallel format in which all the data bits enter their input simultaneously to the parallel input, the register. The data is then read out sequentially in the normal shift right mode from the register. In the theory, for the output waveform for PISO, all input data for the first clock will be added into the shift register simultaneously, collect the load data. Then the data will be shift one by one as it is serial output. This will continue until all the data will be shift out completely. Verilog and VDHL is a hardware description language, HDL. It means by using a HDL, we can describe any digital hardware at any level. Zilink ISE tool is used to develop the Verilog and VHDL design process of PISO shift program. The purpose of this assignment is to create a PISO shift register program in Verilog programming using the Zilink software.
Assalamualaikum and hi, I'm MUSTAQIM. I'm going to explain about Verilog coding and test bench coding. For Verilog coding, first we name our module PISO 4-bit. We declare the parameter for input and output. I declare the clock and include shift as 1-bit input. In variable, I declare it as a 4-bit input because it is parallel 4-bit input from 3 to 0. I declare out as 1-bit output. I don't declare Q as a parameter, but I assign it as unsigned variable to show data is moving. Let's move to the shifting operation. For shifting operation, it will receive output at positive H clock. If load shift value is 1, I declare value of Q equal or lesser than value of in. So, else begin where value of 4-bit 0 to Q3, then Q3 to Q2, and Q2 to Q1, and Q1 to Q0. The result can be seen as the move from LSB to MSB. At the last part, I assign output value out equal to Q0 to form a serial output. Then we write the synthesis. After we run synthesis and implementation design, make sure all of these are in a good condition and there is no error. Right click this, then choose Verilog test feature and next. Next, finish. Then click simulation. So as you can see here at test bench, the inputs were named as rack. As example, this rack clock, rack 4-bit in, and rack load shift. And then the output will declare as wire out. So since I want to put the input as 1001, so I declare value in as 4-bit 1001. The input will happen when value of load shift equal to 1 as initial value. After 10 nanoseconds, I declare load shift as 0 to shift the next output because it is parallel input and serial output. Then I declare hashtag 5 second shift clock. So at each 5 nanosecond, the clock will shift and check behavioral syntax. Since there is no error on behavioral check syntax, so we go to simulation behavioral model.
And this is the waveform that has been generated. At 5 nanosecond, load or shift is 1. So the input 1001 will be shifted here, like this. So the first output will be 1, and then At the second trigger, the second input will be shifted out, which is this 0. It will be 0, and then at second clock trigger, the input will be shifted out 0. It will be 0, and then lastly the MSB, which is 1, will shifted fourth clock trigger here. So the final result will be like this: Q 1 0 0 1.
Next, the pin allocations functions. You can see this is the plan ahead. If you want to assign the pin input and output, you must go to IO planning. This package will appear. As we can see, there is various shapes in this device. We can see the IO planner has been opened in a design, has been loaded, that no logic is highlighted in the device view, just the pin. That is because the code has yet to be associated project. However, the pin have been assigned and we can see a number of the pin color coded to find a particular pin. At this side, we can assign the IO pin. For example, this is AFIQ, so we just assign AFIQ, and next is A7. This is A7, A8, and A9. This window can display pin by IO standard, alphabetically or in other way. But when I find the pin I want, then I click on it and it becomes highlighted in the device view. We can modify it to whatever location we want. The different type of pin also give their own shape, so that the available different pair, we can find the pair easy because there are a shape like this, hexagon, circle, and this is ground. After that, this is how I arrange the flip-flop.
Next, I will explain about the instances. This is the clock in 0 until in 3 is the input load shift here. Then we have the MUX, which are the logic gate, which is here. This is the output at here. Lastly, the Q0 until Q3 is the flip-flop, which is located at here. This flip-flop is this flip-flop, and then in this MUX, which is logic gate, there are 2 AND gate and 1 OR gate. At this one, a truth table will appear. Then from this truth table, we know that in this device there is a logic gate. And next, I will show the netlist. For example, this is the generate the clock. There are 5 pin connected. So basically, this netlist to show the programmer for the connection for each component. Next, I will show the input and output port for this diagram. So as we can see, there are 7 input and output port. This is the first one. The first one they are located at here, and for the second input until the 5th input are located at here, and this is the 6th input, and lastly 7 is the output and it is located at here.
Conclusion: in this assignment, the students have constructed 4-bit PISO shift register Verilog code. Zilink software is used to simulate the code. The software is used because it is much easier and yet can execute block diagram, waveform, and some function required in this assignment. It was verified and proven to function successfully through Zilink software, and block diagram and the waveform were executed after some processes performed as described in methodology part. There were some challenges that have been faced during the implementation of this project, such as license error, cannot run the code, and need to modify some block diagram. However, the students have overcome these challenges successfully by referring to the notes, asking help from friends, and also by referring to the lecturer. That's all from us. Thank you.